Okay, angles in a parallelogram or rhombus, right? Now these two shapes I put together in this video because they are very, very similar, right? Parallelogram, quite simply, you've got opposite sides parallel. Okay, so let's just remind ourselves what a parallelogram is down here. So you've got opposite sides parallel. Okay, in other words, they go in the same direction, right? So that side there is parallel to this. This side here is parallel to this. So I use a single arrow to show they are parallel, double arrow to show they are parallel. So opposite sides parallel. Right? And also what's true is the opposite angles are equal. Okay? So opposite angles are equal. Right? It doesn't mean all the angles are the same, it just means that the opposite ones are equal. So that is equal to that. And this angle here is obviously a bigger angle. It will be the same as this. Alright? Think of a parallelogram as a rectangle that's been shoved, that's been pushed. Similar idea to a rhombus, except with a rhombus, right? It's a special, if you like, it's just like sort of like a special parallelogram because all the sides are equal in length. Okay, so again we have this idea where opposite sides are parallel, opposite angles are equal. Okay, but in this case as well, all sides are also equal. Okay, in a rhombus, all sides are equal as well, whereas that's not the case with a parallelogram. Only the opposite sides are equal in a parallelogram. Okay, let's get to the question. It says ABCD is a rhombus with ADB is 37. Find the size of angle X. Now, remember what he said earlier with a rhombus. Okay, all the sides are equal in length. Yeah, because a rhombus, remember now, ultimately it's a square that's being shoved, so to speak. Okay, all the sides are equal in length. We could put dashes to show that. Now, what's going to help in this case, right? Because this has been split up into triangles. If we know those two sides are the same, which they are, because there's a rhombus. Think about what sort of triangle we've got here. Two sides the same. Of course, it's isosceles, isn't it? It's isosceles. So if we know that's the case, this is also going to be 37 as well. Okay, because it's an isosceles triangle. And also then, because you know these two angles, you can work out this angle here at A, can't you? Because it's a triangle. They add up to 180. So 37, 37, let's add them. 7 and 7 is 14, so 4 carry 1. 3 and 3 is 6, plus 1 is 7, so 74. So then we just see what's left from 180. Okay, and that will give you the angle at A. So that comes out to be 106, doesn't it? Okay, so the angle here is at 106, which makes all them add up to 180. But don't forget then, the most important idea with both of these shapes is the opposite angles are equal. So if we know that's 106, well, we know X, don't we? We can say X is also 106. Okay? That's 106 because in a rhombus or parallelogram, opposite angles are equal. Okay? Right, let's look at a second question here. Now in this case, it's a parallelogram. Okay, they state quite clearly here that it's a parallelogram, and we've got different angles given. Right, so we've got BCD is 60 degrees. Okay, we've got a 33 degree there. Of course, this parallelogram is the diagonal has been drawn, and also there's this other line that's been drawn here. It looks quite complicated, but if you use the ideas of a parallelogram, it becomes really simple. Okay, now what I've noticed here, okay, which I think is going to help, is, can you see we've got a triangle here, right? This triangle here, and I can actually work up this angle, can't I? Yeah. Try and work things out, right? That maybe have nothing to do with that x. Okay. At the moment, to find x, it looks quite complicated, but try and work other things out, and it might open things up for us. So if I work up that angle there, I can do that, can't I? Because I've got a triangle. So add what you know. So you've got 108, 33. Let's add them. So 8 and 3 is 11. 1 carry 1. 0 and 3 is 3. Plus 1 is 4. We've got 1 there. So 1, 4, 1. So then 180 then. Let's see what's left. Okay. 180. 0 take away 1 is not possible. So 10 take away 1 is 9. 7 take away 4 is 3. So 39, isn't it? 39. So this angle here is 39 to complete that triangle. And now I can easily find my angle x. Right? It's easy. You might be able to see it already, but if not, don't worry. Remember the idea of a parallelogram? Opposite angles are equal. So this big angle here, 60, is equal to this angle there, 60. So basically those two will add up to 60. In other words, x and 39, those two angles there have got to be 60. So you can easily then work out where x is. X has got to be 21, isn't it? Yeah, because if x is 21, 39 added to it will give me 60. Okay. Right, so with question 3 here then, ABCD is a parallelogram. All the angles are measured in degrees. Find the size of BCD. So BCD, right, B, C to D, so where the roof is above the C, that's the angle we want here. Now clearly we can't work out this straight away. We don't actually know any angle as it stands. We just have these angles in terms of x. So we've got algebra involved. But remember, keep it simple, right? This is worth 5 marks. So you're not going to get straight to the answer, alright, directly. But keep the idea simple. We know, of course, in a parallelogram, opposite angles are equal. Okay, so we know that in this case now, the opposite angles here, that's 6x minus 25, that's what that angle is equal to this angle. Okay, so you just got yourself some algebra. Now when it comes to this then, because those two are equal, just get the x's one side, numbers on the other side. So I take the 3x over, from 6x minus 3x, and if I take that minus 25 over that side, it comes a plus 25. Okay, that's 3x, that's 45, and of course x will equal 45 divided by 3, because remember now you're doing the opposite, times in there, so you take it over, divide, so x will equal 15. So I figured out x, right? Done some algebra here. I figured out x because ultimately these two are equal using a simple idea that opposite angles are equal. Okay, put them equal and I figured out what x is. What's great about this is now I can actually work out what that angle is, because 3x plus 20, now x is 15, so it'll be 3 times 15 plus 20, yeah, if x is 15, substitute it in, 3 times 15 is 45, plus 20 is 65. I can do the same up here, 6x minus 25, well 15, isn't it? That's what x is, so 6 times 15, take away 25, 6 times 15 is 90, take away 25, of course you can end up with 65, we'd expect that. So we know that's 65, and of course that has to be 65 as well. Keeping it simple, ideas of a parallelogram, opposite angles are equal, that's equal to that, but also, okay, this is equal to this. I can work this out now. We know in a quadrilateral, all the angles add up to 360. So if I add those two 65s together, okay, the ones I know, that's 10, isn't it? 0 carry 1, that's 12, plus the 1 is 13. So 130, so we just got to take that away from 360 now to see what's left. So I take that away, I end up with 230 degrees. So those two angles here add up to 30. So to get one of them, I just have to split it into 2. 2 into 2 goes once, 2 into 3 goes once, remainder 1, 2 into 10 goes 5 times. So angle BCD is 115 degrees. Okay, to finish off, this looks quite complicated. It's actually really easy using those ideas again. Diagram shows a parallelogram ABCD. ADB is 17. So A to D to B, this angle here is 17. ABC is 40. So ABC, so that big angle there at B is 40. Okay. Find then ADC. So ADC is this big angle here at D, right? ADC. Of course, it's got to be the same as that, isn't it? Opposite angles equal, so it's 40 degrees. Then it asks for DBC. So there's D. There's DBC. So we want this little angle here. Now we've already got information that being 17. So you might think, well, how does that relate to that? Okay. You notice you've got a Z angle here. Z angle. So that's also going to be 17 as well. Okay. If you wanted to, you could fill that in. You know that's going to be 23, don't you know? And then of course that's got to be 23 as well. Then it says BCD. So BC to D, you want this bigger angle here. Again, using our simple ideas, we know now all of that's 40. We know that obviously that's 40. So they add up to 80, don't they? Okay, they add up to 80. So we see what's left now in our quadrilateral. 360, it should add up to, we take away the 80. Okay, and take that away, you end up with 280. So 280 then shared amongst those two. Okay, 2 into 2 goes once, 2 into 8 goes 4 times, 140. Okay, so that's our angle there, 140 degrees.